Here's the data as a spreadsheet. For 75 regions in England, we can see that we've got data on the disposable income per head and also the density of fast food outlets. So we can plot the data into a scatter diagram as shown here. Most of the data points seem to lie in this area, highlighted here with the circle, and there does appear to be a trend, as shown by the line. There are, however, 5 data points that don't appear to fit the trend. It is probably worth investigating these data points, for if they are included, the trend line would look very different. Let's examine this point first of all. It appears to have a higher y-coordinate than the other points with a similar x-coordinate. That is, this point appears to have a noticeably higher number of fast food outlets compared to the other points with a similar disposable income. If I hover over the point, I can see that it has a y-coordinate of 192.9. I can now check this out in the table over here and see which particular region of England this data point comes from. I can sort the data in this column from largest to smallest because I want the highest number to be at the top. Now that the data has been sorted, I can see that this point, with a y-coordinate of 192.9, is Blackpool. Pause the video and think. Why would Blackpool have more fast food outlets than other regions with a similar disposable income? Is there something special or different about Blackpool? One possibility is that Blackpool is a seaside resort and therefore needs to cater not only for people who live there, but also for visitors that come during the day or stay. Having lots of visitors might also explain why Westminster has lots of fast food outlets as well. That explains these 2 points. But what about the other 3 points? Now these 3 points, plus Westminster, which we've just looked at, have high disposable incomes compared to the main cluster of data. So if I sort the data by disposable income, I can find out where they are. Now that the data is sorted, we have Kensington and Chelsea, Camden, and Wandsworth, which are all areas of London. So it might be that these places need to cater for more people, not just for those people who live there, but for visitors and people commuting to work. In situations like this, where there appears to be data points that lie well away from the other observations, and there seems to be a reasonable explanation as to why this is, then we may consider these as being outliers and so remove them from the data. Let's look at what happens when I delete the outliers. The diagram certainly looks different. The data points appear to be more spread out, but that's because the spreadsheet software has changed the scale of the horizontal and vertical axes, or the x-axis and the y-axis. So let's reset the y-axis. And let's reset the x-axis in the same way. And now the diagram looks like the original diagram, but with the outliers removed.